Hello everyone, welcome to Edupedia World Videos. In our today's lecture of carbon and its compounds, we are going to cover about covalent bond, versatile nature of carbon and properties of covalent compounds. Bonding in carbon compounds, the covalent bond. Carbon belongs to the group 14 of the periodic table. It has 6 protons and 6 electrons and its electronic configuration is 2,4. The ionization energy of carbon is very high, which is 1086 kJ per mole, and its electronegativity is 2.55, which is neither too low nor too high. The ionization energy and electronegativity values indicate that carbon has no tendency to lose or gain electrons. No compound with a +4 cation is known in carbon and other group 14 elements. A huge amount of energy is needed to remove 4 electrons, leaving behind a C4 positive cation having 6 protons holding on to only 2 electrons. The formation of C4 negative anion is also difficult since the C4 negative anion would have only 6 protons holding on to 10 electrons. The electron-rich C4 negative anion having 4 extra electrons would be unstable. Instead of attaining the noble gas configuration through a C4 positive cation or C4 negative anion, carbon attains the desired noble gas electronic configuration by mutual sharing of electrons and forming 4 single covalent bonds. The shared electrons forming the covalent bond belong to the outer shells of both the atoms. A bond formed by the mutual sharing of an electron pair between 2 atoms is called covalent bond. Not only carbon but many other elements such as nitrogen, phosphorus, oxygen, sulfur, chlorine, etc. form covalent compounds by mutual sharing of electrons. Now we will discuss versatile nature of carbon. Carbon is a versatile element and it exhibits many unique properties. In the beginning, we have discussed some unique properties and important uses of carbon. Now we will discuss some unique properties of carbon which are responsible for its versatile nature. First property is formation of both inorganic and organic compounds. Carbon forms both inorganic and organic compounds. The compounds of carbon with other elements such as silicon, oxygen, sulfur, halogens and metals are called inorganic compounds of carbon. The examples are SiC, CO, CO2, CaC2, etc. The compounds of carbon with hydrogen and their derivatives which contain carbon-carbon bonds are called organic compounds. The examples are methane, ethane, propane, butane, methanol, ethanol, sugar, starch, oils, proteins, amino acids, etc. The second property is catenation. Due to strong and stable nature of carbon-carbon bond, carbon exhibits the unique property to form bonds with other carbon atoms, giving rise to a large straight chain compounds, branch chain compounds and rings of carbon atoms. This property is known as catenation. Due to catenation, carbon forms a large number of compounds. It has the unique property to make a bond with another carbon atoms and forming single bond, double bond or triple bond. The compounds of carbon in which a carbon atom is bonded to another carbon atom by a single bond are known as saturated compounds. The compounds of carbon in which a carbon atom is bonded to another carbon atom by a double or triple bond are called unsaturated compounds. Although some other elements such as silicon, phosphorus, sulfur, selenium also exhibit the property of catenation, the degree of catenation is much less in these elements in comparison to carbon. The third property is tetravalent nature of carbon and formation of multiple covalent bonds with other elements. Instead of attaining noble gas configuration 3 through C4 positive cation, carbon satisfies its valency by forming 4 single bonds with hydrogen and halogens. Carbon has the tendency to attain octet through the formation of multiple covalent bonds with nitrogen, oxygen, sulfur, etc., giving rise to the formation of compounds with specific properties. Carbon form multiple covalent bonds. The formation of multiple covalent bonds by carbon is attributed to its small atomic radius and strong nature of these covalent multiple bonds. And due to small atomic radius of carbon, the nucleus of carbon can hold onto the shared pair of electrons strongly. The tetravalent nature and catenation are together responsible for the formation of a large number of carbon compounds. We will discuss other topics in our next lecture. Thank you for watching Edupedia World Videos.